Hi, welcome back to Statistics 1. We're up to lecture 12. And in the last lecture, we talked about multiple regression, which is one of the more difficult topics that we'll cover in this course. And in the next two lectures, lectures 13 and 14, we'll cover advanced techniques in multiple regression, moderation, and mediation. Before we do that, I want to take a step back and just talk about the mathematical framework underlying all of these approaches. And that is called the general linear model. So the topic for today in lecture 12 is GLM, or general linear model. I've divided this lecture into two segments. First, I'll talk about the general linear model, and then in the second segment, I'll talk about sort of more tedious details, a procedure called dummy coding. So in this first segment, let's talk about the GLM. As I said, it's a mathematical framework that underlies multiple regression, but also analysis of variance, which is a topic that we'll get to after multiple regression. A lot of people think of those two topics as separate. So multiple regression is often taught in one course, and then ANOVA is taught in another course, but analysis of variance, or ANOVA, is just a special case of multiple regression. And you'll see how that's or why that's the case here when I talk about the GLM. So there are two main characteristics of the general linear model, and that is one, that we assume linear relationships between the predictors and the outcome measure, that is between the x's and y, and we assume that the effects of each predictor are additive with one another. But that doesn't mean that the GLM can't handle non-additive or non-linear effects. We can sort of trick the GLM to test those kinds of effects for us. And that's what we're going to do next week when we do moderation, for example. We'll trick the GLM into testing for a non-additive effect or a moderating effect, or in ANOVA we'll call that an interaction. So the GLM can accommodate such tests. For example, with nonlinear relations, we could just transform variables to make them linear and then fit it into the GLM. And as I said, we can add in interaction terms or moderation terms so that we can do a moderation analysis and test for non-additive effects. So let's look at a few examples. So this will help make this more concrete and explain the general framework. So when we looked at a simple regression, we just had one predictor, one outcome. So faculty salary was the outcome, and years since PhD was the predictor. We could do a multiple regression and add in other predictors. So we added in, we had years since the PhD, and then we also added in number of publications. But we could add in a third predictor that's the product of those first two predictors, and that would allow us to test for non-additive effects. It would allow us to see if number of publications moderates the relationship between years since PhD and salary. And you might think that's the case. So perhaps like number of publications matters a lot more for determining salary earlier in your career rather than later. So there might be an interaction or moderation effect. If that were the case, then that predictor X3, that would be a significant predictor of the outcome measure faculty salary. But this is a way that the GLM can handle testing non-additive effects. Notice the GLM, the equation itself, is still linear and additive, but I'm tricking it by throwing in X3, a non-additive effect. So that's how it accommodates these things, and that's what we're going to do next week when we talk about moderation analysis. This is the same exact logic underlying one-way ANOVA and factorial ANOVA, which we'll get to following moderation. It's just that we do ANOVAs sort of in a special case where we have categorical predictors rather than these continuous predictors. So I might predict faculty salary from, say, just gender. That's a categorical predictor. Remember, it's a nominal variable. That's different from like number of years since the PhD or number of publications where we can assume a nice continuous normal distribution. This is a different case. So when we have categorical predictors, we'll do ANOVA. And just as we did with the multiple regression testing for moderation effects, we can test for interaction effects in ANOVA. So I could put in gender as one predictor, race as another predictor, again, a categorical predictor. And then for X3, the third predictor, I could look at the interaction of gender and race. And does that interaction effect predict faculty salary? Again, notice the GLM itself is linear and additive, and it's just handling categorical predictors here, and that's why it's an ANOVA, and it's a factorial ANOVA because we have multiple predictors. So we'll get to analysis of variance after we cover these other topics in multiple regression, that is moderation and mediation. It's most appropriate for situations where we have true independent variables. So go back to the first week of the course where we talked about the difference between experimental research and correlational research. We typically reserve an analysis of variance for situations where we're doing experimental research, where there's a true independent variable. But we can use it in any case where we have categorical predictors. And if there's only two levels of a categorical predictor, like think of the polio vaccine example where the children were just given either vaccine or placebo, then we could just do a t-test. We don't need to do this fancy analysis of variance. And we'll cover all of that after we cover moderation and mediation. Again, I just wanted to sort of pause before we went into that to demonstrate that the general linear model accommodates all of these kinds of analyses. So to sum up this segment, again, the GLM is just the underlying mathematical framework that we're using, not only for multiple regression, but also going forward for things like ANOVA and factorial ANOVA and t-tests. And the main thing to remember about it is that the framework itself is linear and additive, but we can trick it to test for nonlinear effects or non-additive effects. And in multiple regression, we're going to call that moderation. In factorial ANOVA, we're going to call that interaction.